Hi everyone. We're gonna go over some radicals again, and I think that's gonna be our first lesson while we're studying at home. We're gonna go through three different IXLs with all these different types of problems, and this is gonna um, just help you out. I know some of you guys were not great at radicals, so I'm gonna reteach this basic one again, and some of you guys didn't finish this IXL, so you guys can go back and get it done. So our first problem is square root of 75. Now remember, square roots are looking for pairs. And this, like, the square root of 16 is 4, because 3 times 3 is 9, 2 times 2 is 4, and 4 times 4, we have a pair. That's why they come out of the square root. No more square root. We don't write the square root of 4 is equal to the square root of 2. That's not right. We don't put square roots back in square roots, especially if we add the pair. Okay, so we can take 75. And the basic way I like to teach this is using what I call the box method. So for my box method, I draw a little box, upside down division sign, and I write 75 inside. And ask myself, what's the smallest number I can divide 75 by? Well, we can try 1, but 1 doesn't count because we know everything's divisible by 1. We can try 2, but is 5 even? Only numbers that are even can be divided by 2. Not even. How about 3? We said if I add 7 plus 5 is equal to 12, and can I divide 12 by 3? I'll write that over here so you guys can see. 7 plus 5 is equal to 12, and if I can divide 12 by 3, that means we can divide 75 by 3, and that works for all types of numbers. Again, that's our trick for dividing by 3. So let's go and divide by 3. 3 goes into 7 2 times, remainder 1, right? Because that's really 6. We have 1 left over. And then 3 goes into 15 5 times. Now you might say, Mr. Cole, I know what square root of 25 is. Yeah, and you're right. We can just go ahead and say the square root of 25 is 5. But let's go with the process. 5, 5. Now do you see any pairs? A 2, 5, and 5. We circle our pairs for square roots. Just like what we did over here. Just like what we did over here. We had a pair of numbers, and then the square roots came out nicely. Okay, so square root of this is 5. Square root of leftover, this guy doesn't have any by to pair up with. 5 square root of 3. So we're going to go ahead and type that over here. We're going to hit 5 square root of 3. Good work. Okay, now this next problem real quick. Square root of 50. Some of you guys might see the perfect square inside already. And 50 can be written in a lot of different ways. It's 5 times 10. It's 2 times 25. It's 1 times 50. But only one of these pairs have a perfect square in it. And if you guys see it, it's a 25. 25 and 2. Now, if can I take a square root of either of these numbers? We just said we could take a square root of 25. So take a square root of 25. Let's take the square root of 2. The square root of 25 is 5. But I can't take a square root of 2, so that's left inside. If we do this with the box method, smallest number I can divide by 50 is 2. 2 goes into 5. 2 goes into 5. 2 times. Leaving us a remainder 1. And 2 goes into 10 5 times. Hey, we have our 25 again. 5, 5. We have a pair. Let's take that pair out. 5 on the outside and 2 on the inside. 5 square root of 2. Great work. Okay, let's jump to a couple levels here. Now, this one looks a little messy, right? Well, we said 6 on the outside and the square root of 175 on the inside. Now, which one do we have to take care of? The 6 is already on the outside. We have to worry about the square root of 175. So I don't know what the square root of 175 is. So I'm going to draw my box method here. I'm going to start dividing by numbers. 2, 3, 4 doesn't work. 5, 4, 5. I can try all these. But is this even? Nope. So that's why 2 doesn't work. Let's try 3. 1 plus 7 plus 5 is equal to 13. Now, 13 isn't divisible by 3. That doesn't work either. 4. 4 means it has to be even. It's not even. It's not even. So all we're left with is 5. So let's go ahead and try 5. 5 goes into 17. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So 3 times. Remainder 2. 5 goes into 25 5 times. Hey, 35. I know 35. That's 7 and 5, right? So I'm going to pick the smallest number, 5. 5 goes into 35 7 times. When we reflect, are there any pairs? Yes. So that guy gets thrown outside of my square root. So it's going to be 6 times 5. Left over, this guy's stuck inside the square root. What do we do with these numbers on the outside? It's not 65. We're multiplying. So it's going to be 30 square root of 7. 30 square root of 7. Numbers on the outside, multiply. Numbers left over on the inside, multiply together. Let's go ahead and type that. 30 square root of 7. Good job. All right. Let's go on and jump to another level. The last one is just a large number. And if I say the square root of 363. Okay, the square is 363. I don't know what that is. Let's go ahead and use our tricks. We can try dividing by 2, but that's not even, is it? So we can try 3. So I'm going to draw my box method. 2, darn it, not 2. 363. And we can check 3 plus 6 plus 3. That adds up to 12. And 12 can be divided by 3. That's a win. Let's use 3. 3 goes into 3, 6, and 3, right? 3 goes into 3 one time. 3 goes into 2 times. And 3 goes into 3 one time. Okay, can we find out what goes into 121? Well, we can try 121. If we add them up, that's 5. So we know it doesn't work with 3, right? Sad. But if you remember your multiplication tables, what multiplies to become 121? 11. Some of you guys said that probably. 11. So this gets thrown out because it's a pair, and the 3 is left inside. 11 on the outside, square root of 3 on the inside. Let's go ahead and see if that works. Square roots take out perfect squares. They take out square. We call them the square root. What root value gives you that square value? 11 radical 3. Okay, that should be it. Excellent. Great job. Okay. So you can always pause these videos if you are ever stuck or if you want to go back. So let's go through the next one we have here. We're going to work on right here, simplifying we're going to be right here, simplifying radical expressions with variables. Okay, let's go. Now, as you notice, we not only have, let's write this down. It's going to be square root of 50 w squared. We not only have numbers and we have variables, and we treat them separately. Don't overthink it. We'll take the square root of 50 by itself, and then we'll take the square root of w squared by itself. So we actually did the square root of 50 just a moment ago, but let's do it again. The square root of 50, draw the box method, 50. We can divide by what's the smallest number? 2. That gives us 25. We're going to break that down to 5 and 5. Do you see any pairs? Of course you do. That gets thrown out. Remember, that gets thrown outside, and the 2 is stuck on inside. So we write 5, radical 2. But what about the w squared? Do we have a pair of w's here? W and w? Well, we do. So those pair gets to go out too. Those guys get thrown out also. So it's 5w left over 2, because 2, no pairs. Do we have a pair for w's? Yeah, remember this used to be w squared. Do you have a pair for 5's? Yeah, that used to be 25. Right? And when we took the square root, that gave us our 5 and our w. Let's go ahead and try plugging that in. 5w, the letter w, square root of 2. Keep it up. All right. Let's do the next one. It's a square root of 75b to the 6th. Now, let's break up these numbers. Remember, we'll do 75, and then we'll do the letters next. So 75, we did this number actually just on our last problem, I think. You can't divide by 2 because it's not even. So we can divide by 3, because 7 plus 5 is equal to 12, and we can divide 12 by 3. That's a win. And divide by 3, and this gives us 3 goes into 7, 2 times, remainder 1. 3 goes into 15, 5 times. Can we divide 25? Yes, we can. That's 5 and 5. We have a pair again. 5 on the outside, left over 3 inside the square root. Now let's take a look at the b to the 6th power. That's 1, sorry, that's a b. 1, 2, 3, dot, 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 4, 5, 6, dot, dot. We have 1 pair, 2 pair, 3 pairs. So when we take a square root of all these b's, that leaves us a b on the outside, another b on the outside, and another b on the outside. Any b's left? Nope. So what happens when we have b, b, and b on the outside? That's going to be, b cubed. So we deal with the numbers and letters separately to make our lives a lot easier. Let's go and type that in. We're going to type in 5b cubed. I'm going to step out, square root of 3, and we'll see how that goes. All right. So what about this problem here, where they're same idea, was very similar problem like we had before. Square root of 50, r cubed. Sorry, this line is terrible. Okay. Again, we do the numbers first. 50, 2 goes into 50, leaving me 25. 5 and 5. The pair of 5s. That's on the outside. Inside, the 2 has no pair, so we leave him behind. Remember, anytime we don't have a pair, we leave him behind. And how about the r's? Let's write them out. 1, 2, 3. We have a pair. So our pair r's goes out. And just like numbers, this r here doesn't have a pair, so he's left behind. And that's our answers. 5 on the outside, r, radical 2r. Okay, let's go ahead and kick up the levels. Oh, okay. Okay, let's do this one. 8 radical 45 x to the 8th power. So remember radicals, when you don't write nothing here, that's always invisible 2. Invisible 2. Invisible 2. Invisible. Now, 8 is on the outside, so we're not worried about it. 8's on the outside, so we're not worried about it, because it's already outside the radical. The 45, though, we have to break that down. So let's go ahead and break it down. Square root of 45. I can't do 2 because it's odd, but let's try 3. 4 plus 5, 3? 4 plus 5 is 9, and I can divide 9 by 3. Yep, this rule will work. Divide by 3. 3 goes into 4, 1 time, remainder 1. 3 goes into 15, 5 times. And 15 we know. 15 is 3 and 5. Now, did you see the pair coming? Did you see a pair of 3s? Well, some of you guys might, because remember we have a fast way of doing this. And the fast way of doing this says, again, just to reteach that element, this is really 9 times 5. And I do know what the square root of 9 is. It's just 3. See? You see that right here? You see the 3's? So you can, if you know what the square root of 9 is, just do that. If not, write it out, which is all fine. So here we go. 8 is already on the outside. We said 3 goes out, also on the outside. We have a 5 left over on the inside. And we still have the x to the 8. Somewhere right here on the side. 1, 2, 3, 4, 5, 6, 7, 8. And now again, this is a slow way of doing it, but it works if you need to visualize it. Some of you guys might see already that x to the 8, well, 8 divided by 4, because I'm looking for pairs, so 8 divided by 2, because I'm looking for pairs, is 4. So we actually have 1, 2, 3, 4 x's on the outside. That's going to be x to the 4th. Multiply these numbers together. 8 times 3 is 24 x to the 4th with a square root of 5 left over inside. And that's our answer. Let's go try that. 24 x to the 4th power, tap, square root of 5. Alright, great job. We have one more to go for today's lesson, and we are going to do this guy right here. I wonder why it does that. I have to tap over here first next time. If I pull that mouse out. So if you see right here, simplifying radicals, expressions involving fractions. Ooh, deadly word, fractions. Okay. Let's go ahead and tap on that. This is EE.3, simplifying radical expressions involving fractions. Okay, so when you have a fraction and a radical, it really is two separate problems. It's going to be the square root of 10 on top and the square root of 9 on bottom. You could try simplifying it first, which is totally okay. Simplifying radicals, if you can simplify the fraction before, that's great. In this case, 10 doesn't simplify with 9, so we'll just do them separately. What is the square root of 10? Let's try here. 10 becomes 2 and 5. Any pairs? No pairs, so you're stuck as the square root of 10. How about the square root of 9? Square root of 9 is 3 and 3. We do have a pair, and probably you guys already knew the square root of 9 is 3. So this will be rewritten as square root of 10 on the top, all over, not square root of 3. Remember, when you take a square root, the square root goes away. We're left with just a 3. And that is our good answer here. We'll see some issues that come up with square roots. But right now, oops, they want us to first write the fraction. Square root of 10. And the bottom is going to be just about 3. Correct, of course I am. I'm just kidding. Now this one, let's go and try this one. Square root of 25 over 9. We said how many square roots we can break this up into. It's going to be a square root of 25 on top and a square root of 9. Do you really have to write the square root separately? No, you don't. I'm just writing it so you guys can see that these are actually two separate square roots. And the square root of 25 is 5, and the square root of 9 is 3. See, we treat them separately. So you can write the fraction 5 over, over 3. Again, like this next problem, the square root of 15, we don't know what the square root of 15 is. But we do know what the square root of 4 is. So we could break it up if you want to write it. But again, we're taking the square root of 15 and the square root of 4. Since we can't take the square root of 4, it's just 2. And we're left with a square root of 15 on top. And really, once we practice this, the fraction versions of radicals are actually quite simple. There are, again, some caveats here, and we'll get to those. Okay. This one seems pretty good. The square root of 4 over 50. Could I reduce 4 and 50 to begin with? This is 2 and 2, and this is 2 and 25. Yeah, I could. Looks like I can. I can divide them both by 2. And we're left with, so if I do that, we're left with the square root of 2 over 25. And as we mentioned before, we take the square roots of them separately. Square root of 2 and the square root of 25. Do we know what the square root of 25 is? Yes, we do. The square root of 25 is just 5. This is actually our answer. Oops, sorry. 5. Okay, let's jump to something a little harder. So if we take a look at this problem here, let's go ahead and do what we were going to do before. 4k to the 4th power over 75. We'll break this up into two square roots. A square root of 4k to the 4th power on top and 75 on the bottom. Well, do we know what the square root of 4 is? That's just 2. Do we know what the square root of k to the 4 is? 1, 2, 3, 4. Hey, we do have two pairs. That's k squared, because we have two of them, all over. Let's look at the square root of 75. I'm going to do that on the bottom here. Square root of 75. I'm going to draw my box method. I didn't need to write that. So the box method is 75. Smallest number I can divide by is not 2. Let's try 3. 7 plus 5 is 12. Hey, I can divide that by 3. That's a win. Divide by 3 becomes 25. And we know what the square root of 25 is. It's a pair of 5s. 5 radical 3. Now if you look, I'm going to type this and it's going to give me the wrong answer. And we'll talk about why. I'm going to type 2. Oh, sorry, I need a fraction. I forgot. We need 2k squared. On the bottom, we're going to type 5 radical 3. Let's see if this is going to give it to me. Incorrect. And please look at their answer. Their answer. Please look at their answer versus. Look at their answer versus our answer here. Our answer here. Let me write those out. They wrote 2. They wrote 2k squared, square root of 3, over 15. And we wrote 2k squared over 5 square root of 3. Now, can you guys see how their answer and our answer are similar and where it differs? Sorry, I lost that too. Can you see where our answers are similar or all their answers are similar and where they differ? If you look at it, we both have a 2. They both have k squared. Okay. 15 on the bottom. 15 on the bottom is really the numbers 5. Sorry, let me try that low. Older. 5 times 3. So don't we have a 5 also? Oops. Don't we have a 5 also? Now if you notice, the biggest deal here is this guy. So here is what you have to do when you have a square root on the denominator. No square roots on the denominator. And this is a big rule in Algebra 1 and Algebra 2. No square roots on the denominator. So how do we do that? So let's take away all the fluff and we'll write down right now this value. Let's go back and write this. So let's talk about it. What do I need to get that square root of 3, that 3 out of the square root? Well, don't square roots take out pairs? So do I have a pair of 3's inside the square root? I don't. I don't have a pair of 3's here, right? I don't have that. I don't have that pair. I really need, if I had a 3 here, right? If we had a 3, we'd be golden. But we don't have a 3. So the trick is, something you have to memorize, you have to multiply it by the same radical to the top and bottom. Let me write that again. We're going to multiply this by a radical 3 on the bottom and a radical 3 on top. Because what's square root of 3 over 3? What's a number over itself? This guy's really equal to 1. I'm just like when we deal with fractions, I'm not changing the value, I'm just changing the way it looks. My version of plastic surgery. So when we multiply this out, the square root of 3 goes to the top, and the square root of 3 goes to the bottom. So we're left with 2k squared, square root of 3. It just attaches on it, because the square root can't talk to anyone outside the square root. And on the bottom, we said, hey, square root of 3, square root of 3. Don't we have 2 square roots now? 2 square root of 3's. Then we end up with the square root of 9. This is really the square root of 9, which is really just 3 on the outside. We have a pair now. We gave ourselves a pair. And we can multiply those together. 2k squared, square root of 3 over 15. And that is their answer. If you go ahead and take a look here, that's their answer up here also. Go take a look. It's 2k squared, square root of 3 over 15. That's their answer over here. So you can't leave square roots on the denominator. We'll do it one more time with one more problem. And one more time, one more problem. So we got it. Okay. Now, let's see. So not this one. Okay. Here we go. The square root of 63 over 10a to the 9th. Okay, so remember this is 2 square roots really, 2 square roots really. So the square root of 63 and the square root of 10a to the 9th power. 63 and 10, they don't reduce at all. I will see that in just a moment. Let's go ahead and break down the 63 on the side. So draw the box method. 63. Since that's odd, we can't use 2's to divide it out. Let's use 3's, because 6 plus 3 is 9. And we can divide 9 by 3. That's a win. Let's do by 3. 3 goes into 6 2 times. Remainder 0. 3 goes into 6 2 times. And 3 goes into 3 1 time. Let's break down 21. That's 3 and 7. And I do have a pair. So on the top of my fraction, for sure, it's 3 square root of 7 all over. Let's look at the number 10. That's 2 and 2 that goes into 10 5 times. Any pairs at all? No pairs at all. So I'm gonna write square root of 10 there. No pairs at all. A to the 9. A, 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 A. That's 6, 7, 8, 9. 1 pair, 2 pair, 3 pair, 4 pairs, and right. A to the 8 is 4 A's. So these go out. A to the 4th, that's out. But remember, we need pairs. And this guy here, sad A, you're still left inside. Now, we're not done yet. And this problem does look a little messy, and I agree. But we can't leave square roots on the bottom. That's just something we're not allowed to do. So let's go ahead and think of a way again. How can we get rid of that square root from the bottom? How can we get rid of that square root from the bottom? So we're gonna multiply this guy by its own square root, the same exact square root. 10a. You get a 10a? Let me do that in color so you guys can see a little better. So square root of 10a over square root of 10a. Okay. 10 times 10, 10 times 10 is 100. Square root of 100 is 10. And a and a, we have two a's. Those come out. So it's going to be 3 on top over 10 came out. We have another a. Remember how we have another a here? We have 10a that needs to go out. A to the 5th. And no more square roots. No more square roots. Let's rewrite that a little nicer. Use black so you guys can see. So we have 3 on top. We're going to deal with the square root a little bit in a little bit. We said we have 10 and the a becomes 10a to the 5th power. There are no more square roots on the denominator. Square root, because remember we got rid of this all. We got rid of it. Because we found a pair. Now, square roots multiply square roots. Square roots multiply square roots. So 7 times 10 is 70. And we leave the a by itself. So let's go ahead. 3. So we need to write a fraction first, I'm sorry. 3 square root of 70a divided by 10a to the 5th power. Ooh, yeah, that worked. Okay, that was it. So practice that. You can rewatch the video, rewatch the parts of what you need help with. If you have any messages, you can always email me through Schoology, message me through Schoology, and I'll have something else for you guys tomorrow. Thank you.